All right, so guys, what we're going to be talking about today are a special type of quadrilateral. Special IAL quadrilateral. Now, these are two of the words that I spell wrong most frequently. I don't even know if they're spelled correctly here. But we're talking about special quadrilaterals. Can anyone remind me what a quadrilateral is? A four-sided shape, thank you. Any four-sided shape. Can anyone tell me any special quadrilaterals they may know? The square is a special quadrilateral. Trapezoid is a special quadrilateral. A rectangle is a special quadrilateral. Rhombus, which is also a diamond, also very good. That is not a quadrilateral because it has 8 sides. Now, these special type of quadrilaterals we're going to be talking about today encompass many of what you guys just said. There's many special quadrilaterals, but the big overarching special quadrilateral is called a parallelogram. And what we're going to be talking about today is the definition of a parallelogram and its 4 special properties. There are 4 special properties it has. The parallelogram looks kind of like this. This is what is the generic parallelogram. This is what I have right here. Now, the definition of a parallelogram is what we're going to start with. The definition of a parallelogram, get my pen tool. The definition of a parallelogram is this. Any quadrilateral, first of all, like I said, it needs to be a quadrilateral, is the first characteristic. And the second characteristic, it must have 2 pairs of parallel sides. Hence the name, parallelogram. And again, it is its definition, but it's also a very special quality here. I'm going to call this parallelogram below us, or below the definition. And I'm going to give you a visual definition, because I think a diagram to visualize will be very helpful. So, when I say both sides are 2 pairs of parallel sides, that means the pairs or the sides across from one another are going to be parallel. Notice 2 pairs of parallel sides. When you see one arrow, that means these 2 lines are parallel. In fact, let's give them a name so we can have some reference here. We have point A, B, C, and D. So we can see, because of the arrows, AD is parallel to BC. We can also see that AB is parallel to DC. This is the definition of a parallelogram. Notice again, all it needs is 2 pairs of parallel sides. Emphasis being 2, because there is one special quadrilateral where it only has 1 pair of parallel sides. 2 pairs of parallel sides. Any question on the definition of a parallelogram so far? Everybody good with the notation? Recognizing the arrows. Remember, the arrows say parallel. Yep. You talking about the arrows? Or the shape? No. They could be straight up and down, or they could be slightly off. Great question. That's all strictly notation. This is the definition and visual of the definition. Strictly definition here. What we're going to talk about next are the 4 properties. You guys have this down? All right, so let's move on to the special properties of a parallelogram. Let's make this a little bigger. The first property of a parallelogram. I'm going to refer to this as property 1. Now, this is not a general name for it. In fact, I'm just using it strictly for a reference. Property number 1. So if I say property number 1, that's what I'm talking about. Property number 1 of a parallelogram is opposite sides of a parallelogram are congruent. Here we go. Opposite sides of a parallelogram are congruent. And I'll give you a visual to match this as well. The opposite sides. Notice one dash. Those two sides are congruent. And these two sides are congruent. I'm going to give you guys a numerical example of this as well. If we knew, for example, this was a parallelogram, and this side was 5, and this side was 8.5, or 8 5/10, we could easily determine the other sides. We know the side across would also be 8.5, and the side across from the 5 would also be 5. Very, very easy to set up. If we're going to use a formula, a nice little way to write out a formula for this. Remember, when things are congruent, when we see the word congruent, we should think our formula of blank equals blank. Those opposite sides are going to be equal to one another. So that illustrates property number 1. Let's look at property number 2, which is very similar. Property number 2 deals with the angles in a parallelogram. Property 2 says in a parallelogram, opposite angles are congruent. And again, what I mean by opposite are things across from one another. The angle across from this one is going to be the same here. Those opposite angles will be congruent, as well as the alternate pair of opposite angles will be congruent. In a quadrilateral, opposite angles are going to be the same. So if I knew that this angle here was 100, I would know the angle across from it is also 100. It's very easy. You'll see in our next property how easy it is to fill in all of the angles in a quadrilateral. Property number 3 is more of a corollary to our second property, looking at property 3. Says consecutive angles in a parallelogram are supplementary. Supplementary. And just in case you forgot what supplementary was, this means two angles that add up to 180. Again, that refers to supplementary. Now, consecutive angles, all I mean by that are angles right next to one another. In fact, for example, these two angles are consecutive, as well as the blue angle and this angle are also consecutive. They just mean right next to. Like if you served consecutive terms as a president, there would be the two in a row. So if I knew that this angle was 120, let's say this angle is 120, what would the measure of this angle be? It would be 60. Thank you, Malik. Right? And also, since we know that these are also consecutive, this one should also be 60. It matches up with our corollary, it matches up with that previous property that says, oh wait, opposites are congruent. So what's the measure of this angle going to be? 120. It's very easy to find out all of the angles in a parallelogram if you know one angle in a parallelogram. All right, now our last property, or property number 4. Property number 4 deals with the diagonals of a special quadrilateral. Let me copy one of these and send it over in our next slide. The diagonals, for those of you who don't remember what a diagonal is a line that connects two non-adjacent vertices. So our diagonals here would be connecting these two vertices, as well as connecting these two vertices. These would be our diagonals. This is diagonal. All right, now, when we are working with the diagonals, again, a diagonal connect non-adjacent sides. This has to do with property 4. The diagonals of a parallelogram bisect each other. The diagonals bisect each other, only in a parallelogram. What I mean by bisect is it splits them into two equal pieces. And it'll be the same for both diagonals. For example, in the red diagonal, if I knew this portion was 5, we would have to know the other portion is 5. If I knew that this portion was 7, I would have to know that the other portion is 7. This is very helpful in finding the whole length of the diagonal. The whole length of the blue diagonal would be 14. The whole length of the red diagonal would be 5. This comes from our segment addition postulate. So now we've looked at all 4 properties of a parallelogram, as well as their minor application. In the next video, I'll show more in-depth problems applying all of these properties. Also, make sure you have recorded down the definition. The definition is very, very helpful in applying this to other aspects of parallelograms. Thank you.